Alright class, welcome to our 4.6 video. This is going to be on solving systems. You won't see a lot of this on our exam, this is just some extra practice. And basically how we're able to solve more of those problems that involve two variables, such as the first video we did with x and y. So you'll see a lot of this in Algebra 2. I just thought we'd go over this just in case a problem like this does appear on your exam or on another quiz. You kind of know how to set this up, and it's just extra practice with solving equations, and that never hurts. So solve one of the equations, solving systems, there's two different ways. There's solving systems by substitution, and there's solving systems by elimination. We'll talk about solving systems by substitution first. So you'll solve one of the equations for one of the variables. So that's the first step. And then the second step is to substitute solution from step 1 into the second equation. The third step is to solve for the remaining variable. And then the fourth step is to substitute the values from step 3, or the value found from step 3, into first equation to solve for other variable. The equation to solve for other variable. And just a few keywords. Infinitely many solutions to the systems is if both variables cancel and what is left is a consistent statement, then the solution has infinitely many solutions. And then if both variables cancel and what is left is an inconsistent, so meaning not true, an inconsistent statement, then this has no solutions. So we'll go through some examples. So our first example, they kind of do the first couple steps for us. So we have two equations, 10x plus 2y equals 10, and we have y is equal to negative 10. So the second step says we're going to substitute solution from step 1 into second equation. Well, they already solved for one of our equations, this y is equal to 10 for us. So we're simply going to insert y equals 10, or negative 10, in for y. So we have 10x plus 2 times negative 10 equals 10. So it's just a matter of simplifying. So 10x, 2 times negative 10 is a negative 20, is equal to 10. And solving for x, we're going to add 20 to both sides. So we get 10x is equal to 30. Divide by 10 to get the x alone. And we have x is equal to 3. And we don't even need to solve for y because they tell us that y is negative 10. So y is equal to negative 10. So those are our solutions for that system of equation. The next one, once again, they kind of already solved for us. They've solved for y. They've solved for one of the variables. So just like the last problem, we're going to insert 2x plus 3 in for y in the first equation. So we have 15x minus 5 times y, which is 2x plus 3, according to this equation here, is equal to 30. So distributing this negative 5 to both the 2x and 3, we have 15x minus 10x minus 15 is equal to 30. So combining like terms, we have a positive 15 and a negative 10. That's a positive 5x minus 15 is equal to 30. And then solving for x, we're going to add 15 to both sides. And we get 5x is equal to 45, and simply then dividing by 5 to get the x alone. So x is equal to 9. So that's one of our variables. But notice this time they don't tell us what y is equal to. So we can simply put in, this is kind of that fourth step, substitute the value from step 3 into the first equation to solve for the other variable. Well, we can just put it into this equation. You could put it into there and solve for y, but they already have y solved for us. So we can use this one. So y is equal to 2 times our x value, which is 9, plus 3. So y is equal to 18 plus 3, which gives us y is equal to 21. and those are our solutions to the system. So that's solving systems by substitution. The other method is solving systems by elimination. So by elimination, that means to remove, or elimination means to remove. Usually when people solve systems, they usually choose one or the other, whatever one works for them best. I, for some reason, always end up choosing elimination just because I can see what's going on better. But it's up to you. So the first step is to put both equations in standard form. All right, this means ax plus by equals c. That's standard form. And then the second step is you're going to perform necessary operation to make one variable, to make a variable of your choice, so a variable a multiple of each other. We'll go through an example. Each other, kind of going on to the next space here, that's alright. So then the third step is you'll add the two equations together, and then one of the variables should cancel, that's the one that you made a multiple of each other. And then the fourth step is solve for remaining variable. And then the fifth step is to substitute that value into one of the equations and solve for the other variable. So going through our first example here. So we have, let's just zoom in maybe a little. Is it going to let me? No. Alright, so can't zoom in. So we have 4x plus 5y equals 6. 3x minus 5y equals 8. They're both in standard form, which is that ax plus by equals c. And so what we're going to do is notice our y variables are multiples of each other. We have a positive y and a negative y. So we want one positive and we want one negative. So when we add the two together, so I'm going to put a little addition sign. So we get 4x plus 3x gives us 7x. Notice our positive 5y plus a negative 5y gives us 0, so they just disappear, is equal to 6 plus 8, and that is 14. So then simply just solving for x, we're going to divide by 7. X is equal to 2. Right? And then it doesn't matter which one of these two equations that we put x into. So just choosing the top one, 4 times our x, which is 2, so 4 times 2 plus 5y is equal to 6. So we get 8 plus 5y is equal to 6. We subtract 8 from both sides. 5y is equal to negative 2. Notice we're probably not going to have a real nice number here. Divide by 5. So y is equal to negative 2 over 5. We can't reduce that any further. But those are our two solutions. And then our fourth example. Notice we have 3x minus 4y equals 10 and 5x plus 7y equals 3. They are already in standard form, so ax plus by equals c, so we don't need to do any rearranging there. But notice that our x variables, they're not multiples of each other, 3 and 5, not multiples, negative 4 and 7, not multiples. So you're going to just have to choose one that you want to make multiples of each other. And so I'm going to choose, and remember one needs to be positive and one needs to be negative. So I'm just going to choose to get rid of the x's, and I'm going to multiply this whole top row by negative 5. That's how you get the multiples. And I'm going to multiply this whole bottom row by 3. So when you do that, our new equations, so we're going to multiply every single term by negative 5. So 3 times negative 5 is a negative 15x, and then we have negative 5 times a negative 4y is a positive 20y equals a negative 50. So that's this new equation here. So now multiplying the second equation by 3. So we have 3 times 5 is 15x, 3 times 7 is 21y, and 3 times 3 is equal to 9. So now look at negative 15, positive 15. That's exactly what we want. So we're going to add the two together. So negative 15 plus 15, they cancel out. We no longer have our x's. So we're solving for y. So we have 20 plus 21 gives us 41y is equal to negative 50 plus 9, which is a negative 41. So notice, to get the y alone, we divide by 41, and y equals negative 1. So that's one of our solutions. And then from there, it's just a matter of choosing one of our two equations and inserting y equals -1. So we have 5 times -1, I'm choosing the second equation, so plus 7y, oh excuse me, we're solving for x now. So 5x plus 7 times -1 equals 3. So we have 5x minus 7, 7 times -1 equals 3. We're going to add 7 to both sides to get the x alone. 5x equals 10, and then divide by 5. So x is equal to 2. So those are our two solutions. All right. So for the last one, what I'm going to do is I'm going to help you set this up. And then if you come to class with it solved, you turn this in. I'll give you, that will be your homework assignment for this. All right, so find P and Q so that this figure is a parallelogram. So a parallelogram means that opposite sides are parallel. Right. So notice this is where we were kind of struggling before. Notice we have P and Q on both sides, and we didn't even know it, but the last time we solved a problem like this, we were using substitution. But this time, I'm going to help you set up the system, and you can choose elimination or substitution to solve. So if they're parallel, or if they're equal, so we're going to say that 2p plus 3q is equal to 18, and we have 5p minus q is equal to 11. All right. So if you could come to class with that solved, either method works. That'll be your homework assignment.